Hi everyone. In this video, we are going to briefly introduce graphing exponential functions. Let's let b be some constant that's not equal to 1. Then the function f of x equals b to the x, so x is the exponent here, is an exponential function with a base of b. So we call b the base. All right? For b greater than 1, f of x is going to be a function that gets rapidly large as you increase as x goes off to infinity. So the larger x gets, f of x is going to get larger and larger and larger the further you go, and it's going to get larger and larger faster with each iteration. Okay. For b between 0 and 1, f of x will look a little bit like this graph here. Okay. Um, and that is that as you go off to infinity, it's going to get smaller and smaller and smaller. Okay, that's because you're making a fraction smaller and smaller and smaller. It'll forever approach this x-axis here, but it will never cross it. And now as we go off to negative infinity, it's going to get larger and larger and larger. And you notice the exact opposite here for the previous example, right? As you go to negative infinity, it's going to get smaller and smaller and smaller. So yeah, that is what these graphs will look like. Okay. All right. So let's take a look at a couple of examples. The best way to go about graphing one of these is probably just to plug in a few points. I always like to start with 0 and then see what happens as you go to the left and to the right. So if we start with 0, which is this middle point here on our table here for graphing, we will have f of x is equal to 2 to the 0. And anything to the 0 is just 1. So at the point x equals 0, f of x is going to be equal to 1. All right, so let's see what happens if we go to the left of that, okay? If we go to the left, let's do negative 1. We'll have f of x is equal to 2 to the negative 1. And that's actually just the same thing as 1 over 2 to the 1. Remember, the negative exponent means you um, put it 1 over that particular number. Or if it's already a fraction, you just flip the fraction, okay? And then take the exponent. So here we have 2 to the 1, or just 1 half. So if we go x equals negative 1, we'll have the point 1 half, okay? If we go x equals negative 2, we'll have 2 to the negative 2, or this is just 1 over 2 squared, which is 1 over 4. So at x equals negative 2, we'll have 1/4. So it'll be about here, okay? So what you're seeing is as x goes off to negative infinity, it's getting smaller and smaller. If x is negative 3, we'll have 1/8. And negative 4 will give us 1/16, and so on, and so on, and so on. And it's going to get closer and closer to 0, but it's never actually going to touch 0. So what we call this as we're graphing this, as it looks about like that, as it's getting closer and closer to the x-axis where it doesn't touch that, we call that the horizontal asymptote of our exponential function. So if the graph is forever approaching some line, but it never actually touches or crosses it, we call that an asymptote. Some graphs have vertical asymptotes, some graphs have horizontal asymptotes. Exponential functions have horizontal asymptotes. Let's go off to the right though. Let's look at x equals 1. So if we have f of x equals 2 to the 1, that's the same thing as just 2. So at x equals 1, we'll have f of x is equal to 2. Okay, now let's try. X equals 2. So we'll have 2 squared, or 4. So at x equals 2, we'll have f of x is equal to 4. So we see that it's growing rapidly, about like this. And so we can get the general shape of our graph, and it'll look like that. If we have 2 to the 3, that'll be 8. 2 to the 4 is 16, and so on, so on. As you go off to infinity, f of x is going to get larger faster. Okay. And what you'll notice is that f of x, if you have a base of 2 here, this is a really nice example to show what exponential growth looks like. So each time you increase x by 1, the size of f of x doubles. Okay, so you notice you go from 0 well, let's start from 1. If we go from 1 to 2, okay, we go from f of x is equal to 2 to f of x is equal to 4. If we go from 2 to 3, we go from 4 to 8. 3 to 4, we get 8 to 16. So each step, we're actually doubling the size, okay? So that is kind of how exponential functions work. How fast they grow is directly related to this base, which in this case is 2. Okay, so now let's see what happens if we have a base between 0 and 1. So here we have f of x is equal to 1 half raised to the x. All right, so if let's start with 0 again. So here we have 1 half raised to the 0th power, which anything raised to the 0th power is just 1. So at 0, again, we get 1. Okay, so let's go 1 to the left this time. So here we have 1 half raised to the negative 1 power. So remember, with a fraction here, we can just flip the fraction and then make the exponent positive. So we have now 2 over 1 to the 1, or just 2 over 1, which is just 2. Okay, so at negative 1, we get, if x equals negative 1, we get f of x is equal to 2. All right, now let's try x equals negative 2. So we'll have 1 over 2 to the negative 2, and that'd be equal to 2 over 1, 2 over 1 squared, or 2 squared, which is 4. So at x equals negative 2, we get f of x is equal to 4. So now let's try x equals 1. So anything raised to the first power is just itself. So we'll have 1 half to the 1 is equal to just 1 half. Right? And then here we have 1 half squared. So that would be the same thing. We can distribute this now. It would be like 1 squared over 2 squared. 1 squared is just 1, and 2 squared is 4. So we end up with 1/4. Okay, so what you'll notice here is this is actually kind of the opposite of the previous example. As we go to negative infinity, it's doubling with each iteration, and as we go to positive infinity, it's cutting in half by each iteration. Okay, so it's the exact opposite here. So if you flip the base on itself, you get the direct opposite in terms of its growth. All right, so there was a quick introduction to exponential functions. There's a whole lot of applications that we can use these exponential functions in, and we're going to look at a few of those here in just a little bit.